Let's have a look at part D now. So a scientist says that team production would work better if team members care about each other. Okay, how would the conclusions under part C change if workers cared about each other's utility? Now, what matters is this: we still keep the same setting as in part C, meaning we only measure output but not effort. So we measure output, not effort. But what matters now is that we care about the utility of the other guy. So we will have the same utility function as before. Remember, the utility function used to be the income minus the cost of effort, but we will add the utility of the second guy as well, which is symmetrical. Let's write all this thing and we'll see how this works out. So the wage used to be 1/2, because remember, they agree beforehand that they will get half of the output. That's the condition of part C. We keep the same thing over here. 1/2 times beta times the effort levels, so that's going to be E1 plus E2, E1 plus E2 minus the cost of effort of the first guy, right? Because he cares about his cost of effort in this sense. He cares about maximizing his own utility. So 1/2 theta times E1 to the power of 2, but he also cares about the entire utility of the second worker. So plus utility of the second guy. Let me color it differently. Plus utility of the second guy. What do we do now? Well, the utility of the second guy is analogous, is symmetrical to this one. So we will substitute all this thing with respect to the second guy over here, and then we will see what the utility will look like. So we will have U1 equals to. Now let's just be strategic and copy paste this. This is gonna be this thing like that. Copy and paste it over here below. And plus the utility of the second guy. So now we have to write the utility of the second guy. What is that going to be? We'll have the income of the second guy, which is 1/2 times, again, he gets a half of the output, so the same income level. Okay, E1 plus E2, let's write it in the same colors, to make it look nice. E1 plus E2 minus the cost of effort of the second guy. This is what changes. So minus 1/2 theta times E2 to the power of 2, close that bracket. Now what we see? We see that the utility of the first guy depends on his effort levels in more terms. It depends on the effort level over here, and also over here. So when we differentiate now, let me just separate this space. When we differentiate the utility of the first guy with respect to the effort level, make it equal to 0, our result is going to be slightly different than in part C, because we have more terms to differentiate. Let's see how that works out. In the first term, this one over here, when we differentiate it with respect to E1, what do we get? 1/2 times P times beta. That's it. We go to the second term. Minus 1/2 theta E1 to the power of 2. We get 1/2 times theta times E1 squared derivative. That's just 2 times E1. We go to the next term. So over here we have plus 1/2 times all this thing derivative with respect to E1. We get 1/2 P times beta only. That's it. Everything else is related to E2. So the derivative with respect to E1 is just gonna be 0. What we said is that this thing must equal to 0. So we make it equal to 0. Let's cancel out some stuff. 2 and 2 go away. So what do we have now? 1/2 P times beta plus 1/2 P times beta. We're adding the same term with two coefficients. 1/2 plus 1/2 is equal to 1, meaning that as a result we have P times beta from those two, and we take the other term to the other side. So this one, theta times E1 goes over there. So we have as a result theta times E1. Hold on, why did I write theta over here? I see no theta, I'm sorry. That was just, anyway. So effort of the first guy is going to be the same as the effort of the second guy, because remember, this is all symmetrical, so we would get to the same results. The price times beta over theta. So price times beta over theta. Now notice this. This is the effort level with the new setting, that we care about the other worker. What was the effort level in part C where we didn't care about the other worker? Well, the effort level in part C was 1/2 times P times beta over theta. So when we care about other worker, we increase the effort level. We double it by 2, right? This is twice as more as previously. And notice this is the same effort level. So this is the whole thing here, to compare this setting with that in part B where we maximize team utility. When we maximize team utility in part B, somewhere over here, hold on a second, what was it? Yes, P times beta over theta. Do you see that? Same effort level. So maximizing team utility or caring about other worker is the same thing. That's the idea. Either maximize team utility where we agree on the effort beforehand, or if we cannot agree on the effort beforehand, let's care about the other worker. care about other worker. And the whole intuition here is just to suggest two ways to incentivize workers. Either let them, you know, agree to work by themselves as a team, or give them some sort of, you know, how do you call that? Like make them be friends. That's kind of the idea. Make them socialize so that they care about each other, so you get to the same result as maximizing the team utility. So we see that with the effort level, and basically now with the entire math, I think you see the intuition that we're going to prove that everything works out very well with this. The results that we're gonna get in you know, in the next in the next couple of operations, so to speak, is gonna be the same results as with the team utility. So that's what we're trying to prove, and we'll finish this off in the next video.